Hi everyone, welcome to the new video of WRF series. In the previous video, we learned to install, set up a WRF model on Linux machine. Also, we talked about input dataset of WRF and WPS preprocessing part of WRF. In this video, we will see how to run actual code of WRF model. This is a part 3 of WRF model, which is a actual code of model. It has 3 steps. Step 1 name list, step 2 real program, and step 3 WRF program. Mate underscore em is a netcdf file which has interpolated gridded data and geostationary data to the user defined domain. It created using WPS program. The first step of WRF code is to edit namelist.input file. It is a text file which contains the user defined information like start, end date, and time of forecast. Domain specification, atmospheric physics, dynamic parameterization scheme, options. Once namelist.input file edited, then run real.exe program. This program will produce two different files. One is the initial condition, start with the name WRF input, and other is WRF BD for boundary condition for the defined domain. Here XX is the domain number. If you have two domain, then you will get two WRF input and two WRF body files. Here real.exe program uses namelist.input file to understand user defined information and to access the data from mate underscore em netcdf file in order to generate initial and boundary conditions for the model. In the last step of WRF code, run the wrf.exe file and this will produce desired forecast over defined domain. wrf.exe uses initial and boundary conditions from files WRF input and WRF body which created by real.exe. The physics and dynamics and other user defined information accessed by the wrf.exe using namelist.input file. Once WRF model run completes, we get forecast file with the name WRF out underscore d xx. Here XX means the domain number. If you have more than one domain, then you must get more than one WRF out file. Remember, number of WRF out files are always equal to number of defined domains. Now let us discuss the namelist.input basic entries in brief. It has more than 4 sections. The first section is time control. Here run underscore days, run underscore hours, run underscore minutes, and run underscore seconds defines the length of forecast period. Suppose you want to create forecast for next 2 days. Then here run underscore days is 2 and other options are equal to 0, or you can specify the run underscore hours 48 and other run options are equal to 0. So you can choose the option of run as per required forecast time period. Interval seconds, start year, start month, start day, start hour, and end year, end month, end day, end hour have the same value defined in the namelist.wps file inside WPS while running WPS program. Restart option is always false for smaller run forecast like short or medium range. But for seasonal or climate run, it is recommended to make true. So if model stops or fails due to any reason, you may start model again from define restart time interval, which is in seconds. WRF model will write output at each seconds or hours specified in history interval. Frames per out file defines the number of output record to be write in output file by the model. The options IO form defines the input and output file format. Here, to indicate input output file format is netcdf. This is default and recommended option. In the domain section, max underscore dom, e underscore we, e underscore sn, dx, dy, parent id, ij, parent start, parent grid ratio, parent time step ratio has the same value which mentioned in namelist.wps file. Time step value is in seconds. This value is very crucial in terms of CFL condition. The model will integrate the forecast forward in time for each mentioned time step. And thumb rule to select the time step is 5 or 6 multiplied by the horizontal distance between grid in kilometers. Time step num and time step den is used to define time step in fraction. Num underscore made grid soil levels and levels are number of soil level and number of pressure level present in the downloaded gridded data. P underscore top requested is the model pressure at the top of the atmosphere in Pascal. The next section is a physics. This includes various physics options used for the simulation by the model like microphysics, cumulus physics, long and short wave radiation, boundary layer, etc. In the updated version, this list is bigger and also comes with various parameterization for each physics term. Here, in this section, you have to mention appropriate parameterization scheme option of the respective physics term and what that you should refer WRF ARW guide document, which is available on their web under document section. Similar to physics, there is a dynamic section in the name list. It also has various dynamic parameter used by the model during simulation. And again, you have to refer WRF ARW guide for parameterization schemes. The namelist.input has more than 4 sections, but you have to specify as per the requirement of study case all the sections and its respective options of namelist.input you will find on these links. Or you may see namelist.input.default file, the file present inside wrf/test/em_real directory. With this basic understanding, let's run the model. In the last part, we have created mate_em file for 24 September 2024. Now go to wrf/test/em_real directory. Edit namelist.input as per namelist.wps. So we can simulate the forecast over defined domain. After that, run ln space -sf path of mate_em files. Once you have linked the mate_em file, then simply run .real exe program. This will create initial and boundary condition for the model of defined domain. It will take some time to complete. The run depends upon your computer, the hardware, and selected domain size and spatial temporal resolution. If real program encounters any error and stops, then use file rsl dot error dot 4 times 0 to check for the errors. Once real program completes successfully, you will see WRF BD and WRF input files in the same directory. After creation of WRF boundary condition and WRF input condition, now run wrf.exe program. You may run wrf.exe just typing ./wrf.exe, and if you wish to run with parallel processor, then execute command mpi run space -np 2 ./wrf.exe, which will create your desired forecast for the domain. Again, it will take longer time to complete forecast, and all it depends on the computer, hardware, domain resolution and forecast period. Here also, if WRF program encounter the error, check rsl dot error dot 4 times 0 file for the error. After successful run of WRF program, you will get WRF out files which will have the forecast of various parameters of the atmosphere for your desired domain and time. Once WRF out file created, then the fourth part of model, which is post processing. The WRF files can be post processed using various scientific tools or programming languages. NCL by UCAR and WRF Python, these are two prominent tools for post processing WRF data. At given links, you may get basic pre-developed scripts used for the post-processing of the WRF model output. With this, we have completed third and fourth part of WRF model run. In the description of the video, you may find GitHub link of WRF setup script, which is developed by me and tested for local Linux machine like CentOS, Red Hat and Ubuntu. This is a bash script. You may run it by typing bash script name. The script will check all required basic libraries for WRF and also install other necessary libraries for WRF. After WRF libraries, it will download, compile and configure WPS WRF code. In the last step, the script downloads sample data and run test case to create forecast of the model. This script will help you to set up WRF model on Linux machine. With this, we stop here. For more videos, stay connected. Thank you.